All right. Well, welcome everyone to our second session of the Colorado Water Center Faculty Lightning Talk series. My name is Karen Schlatter and I'm the interim director of the Colorado Water Center. And I have to do our mandatory kind of introduction to the Colorado Water Center to make sure everyone knows what we are. So we promote interdisciplinary research, we drive educational programming and facilitate stakeholder engagement all around very complicated water issues in Colorado and the West and beyond. And we do so by fostering collaboration, synthesizing water knowledge, and inspiring the next generation of water leaders. We are housed under the Office of Engagement and Extension at CSU, and we're also the designated USGS Water Resources Research Institute for the state of Colorado, which gives us our statewide mission. We work with a bunch of different stakeholders. We work with our educational institutions, scientific research organizations, water management agencies, and water user groups to address challenges. I'm actually going to move you guys. Okay, so we are here today to have a second session of our Faculty Lightning Talk series. And this is something I started organizing this spring semester, really to just get more sharing and collaboration around water in our research and extension communities at CSU. So if you are interested, you can still sign up. I think based on interest level, we might continue this into the next fall semester and maybe even beyond. So you can still sign up if you're interested. And there's a form you can fill out there and we'll get you grouped by theme is how we're doing it. So folks sign up, we look at the different interests and areas that people want to find more collaborators on, and then we group you together in similar themes. So our first series was back in February, and that was on the intersections of water governance policy and environmental change. And all of these sessions are recorded and posted on our website. So if you missed it and you want to check it out, you can. We have the slides, we have, people's contact information if you want to get in touch with anyone. So here we are today, we're at our second session, which is going to be focused on water quality research and engagement. So this is a cool session in particular, I think, because it brings both the research and engagement extension sides together. So we're going to hear a lot about surface and groundwater quality issues, both from kind of agricultural impacts on water quality and engagement with the agricultural community, to use of biochar to improve water quality, some mining impacts and kind of working with watershed groups, and then private well water quality and stewardship issues. So really excited to have the folks here today. And real quick before I do introductions of them, we have our third session now scheduled. This is going to be May 1st, which I think is a Thursday. So 12:30, and that is not the correct time. It should be 12:30 to 2:15. I'll get that changed. So each one is an hour and 15 minutes. And we will have folks talking about broad efforts to improve water conservation and sustainability, both surface water and groundwater issues. So now I'm going to go and introduce our speakers. The way the Lightning Talk series works is that we have a series of speakers that talk for a very short amount of time, 7 minutes, and I'll be timing you, so watch out. And then we'll take 1 to 2 questions afterwards, kind of clarifying questions or follow-up questions on each speaker. And then we'll have 15 to 20 minutes at the end to have more discussion broadly. And these talks are really meant to both share out externally to the broader CSU community, but also to get more collaboration within this group. And so, who else is doing work in water quality and how can we connect you all? So with that, I will introduce our speakers for today. So Debbie Lee is an assistant professor in the Department of Environmental and Radiological Health Sciences. And we are not going to be speaking in this order, so take that with a grain of salt. This is alphabetical. Derek Lowstuter, sorry, Derek, I might have that wrong, Lowstuter. He's an Extension Mountain Regional Specialist with expanded rural engagement in food and agriculture. And Guinevere Nelson is the Extension Director for Douglas County. And Erik Wardle is the Director of the Ag Water Quality Program of the Department of Soil and Crop Sciences. So I am going to pull up, let me make sure everyone good online. I can see you. Everyone's good online. Okay. So first up, we're going to have Erik Wardle speak, and then we'll go with Derek, Guinevere, and Debbie. And so I'm going to just change out our slides here and get Erik's presentation pulled up. Any questions while I do that? Of course, that's over here. Come back over here. Okay. Is that your first slide?
Yes.
All right. Everybody see that online? Yes. Okay. Thanks for bearing with me. Thumbs up. All right. Thank you, Erik. Take it away.
Yeah, absolutely. Okay. All right. Well, good afternoon, everybody. Thank you. It's very nice to be here for this conversation. So my name is Erik Wardle, as Karen mentioned. I'm the director of the Agricultural Water Quality Program. So our charge, we are a state-funded program, and our charge is to help protect all state waters. So we used to be just a groundwater program. Now we're a ground and surface water program. So all state waters in Colorado, our charge is to help protect those from agricultural chemicals. So we work directly with the agricultural community in Colorado, farmers, ranchers, and ag stakeholder groups. And our goal is to work with that community to help protect water in the state of Colorado. So in this picture, this is a very beautiful ranch just south of Steamboat Springs, Colorado. Looks kind of pristine and natural, and it's all of those things. But this is a working ranch in Colorado. And so no matter where we are in the state of Colorado, we find some influence from agriculture. So it's a very critical part of our economy, and it's part of what we do in the state. Without agriculture, I think Colorado would be a very different place. And so we work with that community, the farming and ranching community, to help protect water. So this is, again, high mountains. This is probably about 7,500 feet. So it's high altitude. But there is there's you can't see it in this picture. Well, you can barely see it, but the reservoir up above, where this is the Yampa River, which runs right through Steamboat. But that reservoir just up above this area is one of the most contaminated water bodies in the state of Colorado. So toxic algae blooms, it gets shut down for any kind of human use pretty regularly, and has a lot of issues. And so there's some opinions that agriculture is having a big impact on this. We actually just completed a 3-year study, excuse me, looking at agriculture in this area and looking at runoff from ranches and animal feeding operations, and really found that the influence of agriculture is extremely low and extremely limited, as we would expect, because mountain meadow hay production and ranching up in this area is a very low input system. You can't really put a lot on and still make a living. So as far as fertilizers and pesticides, the impact of those is extremely low. And so we work really closely with the ag community to look at these things. And the great news, and kind of the theme of my couple minutes here, is we can only do what we do because of our relationship with agriculture. And so the ranching and farming community are extremely engaged in these conversations, and they reach out to us. So most of what I do is, if I can make this advance somehow magically. Let's see, there we go. Okay, good. Okay. Is because of the ag community coming to us and asking us questions. So this next slide, so the gentleman in the kind of in the middle there in the green green shirt, green flannel, His name is Troy Waters. He's a farmer that farms in the Grand Valley. So he's in the Grand Junction area, north of Steamboat, or north of Steamboat. I have Steamboat in my brain from that last beautiful picture. North of Grand Junction, so he's in the Fruita area. So Troy is another individual who reached out to us and asked us to come monitor what he's doing on his farm, because he had some good ideas for how to protect water quality and become more profitable. And so he reached out directly to us and had conversations with us on his operation and wanted us to come out and do some science. And so this is him talking to my team on how we would monitor what he's doing on his farm, making some changes as far as how he irrigates. He also is doing things with nitrification inhibitors, so essentially making his nitrogen fertilizer more sustainable, so that it doesn't run off it won't run off as quick, it won't be quite as plant available as quick, but also so that it doesn't move off of his farm. And so Troy is a really interesting individual. He's been on the Water Quality Control Commission, so he's been involved in kind of the state level politics and other things, but also so this is a picture of he designed his own study essentially. So he took something that, you know, the kind of thing that us nerd scientists will sit in our offices for hours and try to come up with a design for a research study. And he came up with it on his own and then called us and said, here's what I'm doing. Can you guys monitor this? And we said, yeah, we can. And we're going to work with you on how to do that. And so, again, driven 100% by the producer himself. So this was an idea. So this again is a study where he's looking at these nitrification inhibitors. So trying to keep his nitrogen on his field instead of running off where he doesn't want it to be. And this is in the Colorado River Basin, where folks are very concerned with water quantity, obviously, but also water quantity. And so he's taking the initiative on his own with, we have 3 other producers who are also working with us. Again, all of them came to us first to address water quality issues in the Colorado River Basin and trying to better understand how those are impacting not only what they do, but also water quality in the greater sense in the basin. So again, producer driven. And so this last photo, this is showing, so this is us, actually, we're actually at Troy Waters' place here. This was winter week, or I'm sorry, spring week. He was growing that year, putting in our monitoring equipment. So we're monitoring water quality as it comes onto his field and then as it leaves his field, trying to better understand the impact of his operation on water quality in the basin, in the Colorado River Basin. But in this picture, this gentleman on the right is AJ Brown. He's one of my employees. So he's out there installing the equipment in the middle there with the grin. Well, they're all grinning, which I think is wonderful. They're all very happy. But in the middle there, that is Phil Brink. He's a consultant, but his role, he works directly with Colorado Cattlemen's Association. So he's a livestock producer and works with livestock production in the state. They are actively involved with everything that we do. Again, of their own volition. It's not us chasing them, it's them being very actively involved. And then on the left is Greg Peterson. He is the CEO of the Colorado Ag Water Alliance. And so it's ag stakeholder entity. It's folks from basically every ag entity in the state interested in water issues and trying to protect water for agriculture. And so Greg is a driver of these projects that we do, and also very actively engaged and involved. And so for us, what's really critical is this, kind of what you see in this picture, is that connection and engagement from the agricultural side. So we're the scientists and we work directly with the ag community, and it's pushed by ag itself. So the work that we do to protect water quality in the state is again driven by the ag community, and that relationship built on trust. From they know that we're going to be open and honest with our science, and then they're gonna push what their role is and what their goals are as far as improvements. So
All right.
that's what I have for you, final folks.
Thanks, Erik. Questions for Erik, either online or in the room?
I could throw out a quick one.
Emil?
Is the Clean Water Act engaged in this, and CDPHE work with you, or how does that?
100%, yeah. So the Clean Water Act is a big part of what we do. So the non-point source program, which is housed at the state health department, so Department of Health and Environment, they get funds directly from the EPA for Clean Water Act enforcement, but also for promotion of research and engagement. And so, excuse me, many of these projects, including the one I showed at Troy Waters' place in the Grand Valley, those funds come directly from the state health department, which are EPA Clean Water Act funds to protect water in the state. So yeah, there is definitely a relationship with that program and the goals of the Clean Water Act.
Thank you.
Absolutely.
I have a question.
Yeah.
You mentioned, the producers come to you. But in order for them to do that, they have to know about you and they have to know
Yes.
your reputation.
Yes.
And so how do you build that to begin with? How do they get to know you and how do they know to connect with you when they have questions or issues with water quality?
Yeah, that's an important point, and it's so I took over in my role as director of this program in 2018, I believe. But our program started in 1990, and it was Reagan Wascom who then became the director of the Water Center. So I'm sure you know of Reagan. And then my boss took over, and so it really is with the ag community, you don't build a relationship in a year or 2 years or 5 years even, honestly. It's long term, and so it's really about that sort of generational relationship, and also just what's critical about it is just being predictable and reliable. And I think the ag community understands that we're going to present the science, and so if there is major amounts of nitrogen leaving a field, we're going to talk to the producer about that, and we're not going to hide it. And I guess the great thing, or historically, there's been this perception that ag is going to, sort of put their head in the sand. And actually, I have some slides with like an ostrich with his head in the sand that I used to talk to the ag community about, but it's becoming less true, where now some of the mountain meadow hay work or the things we did up in the hills with, again, those sort of low input hay production systems, the ag community is now, anything we come up with, they're much more, they just want to respond. They're like, I'm losing nitrogen, that's money, let's figure out how to fix it. And so there's that. We're not providing them information so they can be regulated, or and the health department has the same approach, which is amazing, right? Where the health department is also, we don't want to regulate the ag community, we want to help them adapt and do better.
Yeah.
And so it's about that relationship and that back and forth conversation, where if something doesn't look good, let's fix it. But then it's also it's that piece of being reliable, right? Where they know what they're going to get from me. They're going to get the science, and they're going to get, I feel very much like a liaison for the ag community. And so I support ag, and I think that their ability to adapt on farm makes way more sense than somebody from Denver or DC trying to regulate them. But it's really about that, supporting them to adapt with the science. So
great.
Yeah.
Well, thanks, Erik. I think we'll transition to our next
Awesome. Thank you.
speaker. And so, Derek, do you want to share your screen? And we'll keep our fingers crossed.
Don't work.
Is that coming up okay?
Yes.
Yep.
Okay. Excellent. Thank you very much. Good afternoon. My name is Derek Lowstuter. I work at CSU Extension. I'm an agriculture and food system specialist, specifically serving the mountain region in Extension, but I do some work statewide. and some of that work is revolving around biochar. So some of you have likely heard of it before, others maybe not. But it can kind of be defined a number of ways, both by what it is and also what it does, how it's used. So it's specialty charcoal that's produced from organic matter decomposed at high temperatures in a low oxygen environment. So really the difference in between pyrolysis, which is this thermochemical decomposition, and combustion is the absence of oxygen. So by excluding oxygen, you're creating this biochar. And it's most commonly used as a soil amendment to achieve target goals for the soil. So that can be increasing porosity while improving nutrient and water holding capacity. And it's also a proven method to remove atmospheric carbon dioxide from the carbon cycle for decades to millennia, depending upon the source of that biochar and then how that soil is managed, thereby reducing greenhouse gases. And significantly, this plays a role in carbon credits, if anyone is involved in that or interested in that. Because when you think about all the carbon credits that have been sold, and of those that have been delivered, 90% of those are biochar based. So it's not, deferred harvest from trees or growing biomass for these credits, or direct air capture, things like that. 90% of the delivered credits has come from biochar. And I like to call biochar it's kind of like an exponential English muffin. So its nooks and crannies have nooks and crannies, and those nooks and crannies have their own nooks and crannies. And so you get this very dynamic structure that can impact the chemical, physical, and even biological characteristics of a soil or really any medium that you put it in. It could be water, for example. And so we have these relic structures that are kind of locked in the biochar like a carbon fossil based on what's used to produce the biochar. So if you use grasses or like bamboo to pyrolyze, then you have that structure in the biochar. Most biochar that we're talking about is wood derived. So you have that structure, the macro and micropores that come from that, again, that carbon relic structure of the wood itself. And then when you look at that picture on the right, that's actually an image of a human lung. That's not biochar. But it's adapted to increasing that interface in between the interior of the body and the exterior environment. And really, that's the way that biochar functions as well. And it has a lot of uses in stormwater management. I'm not going to read all these off, and some of them are kind of related to each other, but things like structural soils for street trees or retention structures, filters, swales. There's lots of different ways that it can be used for stormwater management. And then that works through contaminant removal, supporting plant growth, retaining water, slowly releasing nutrients that are either added to it intentionally or are accumulated within the biochar. And that's a low weight geomedia. So for things like green roofs, it can be used as that substrate. And then when we're talking specifically about waterways and water bodies, there's different ways that it can be applied. So there are these things that I call, like channel diapers. So there are these things that are placed in the channel that are full of biochar and they absorb the contaminants. That's what this project is for. Or you can use socks or waddles that are stuffed with biochar. And specifically, this is to reduce eutrophication in waterways, absorbing excess nutrients that lead to eutrophication. And this is an article that just came out a couple days ago that I thought was interesting. So scientists found this chemical that's actually in tire dust that was killing off salmon. So just to give you an idea, this was a quote from the article talking concentrations are a few drops in an Olympic-sized swimming pool, but just those few drops would kill half the population of salmon that you'd put in the pool. So very dilute, but very powerful. And then the runoff was successfully treated in structures like this using an in-ground mix that was biochar centric. And then also things like microplastic, PFAS, forever chemicals. There's certainly applications for that. And depending upon what the contaminant is, you can either leave that in the site or you can remove it once it's saturated. And then also amending contaminated soils with biochar improves health outcomes for plants and people. Biochar does this by changing contaminant availability through modified ion exchange, physical entrapment, and then changes in the soil chemistry. And then this was a study that showed amending heavy metal polluted soils with biochar reduced the cancer risk by more than 30%. And this was based on plant uptake of those contaminants and then human consumption of that plant. This also has applications in mine reclamation or disturbed land in general. So by applying biochar in these, orphaned or abandoned mine sites, you can improve soil structure so it can improve, phytoremediation, plant uptake and sequestration of these contaminants, can raise soil pH depending upon the biochar that's used, provides a lot of surface area for microorganisms to colonize and help either bind or break up those contaminants. And then negatively charged surface allows heavy metal cations to be absorbed, making them less soluble, so less likely to be washed out, and also less bioavailable. Here's an example of a reclamation site near Aspen, Colorado, a fairly well-known site. So on the left, it's before biochar application, and then on the right, it's after a year more or less of growth, revegetation from that biochar application on this really contaminated and rocky talus slope. And then agricultural applications of biochar. It increases water infiltration and percolation, water retention, but also water availability within these soils, which is important for drought planning. And there's a lot of interest in using biochar as kind of the substrate for either conventional or organic fertilizers. So creating naturally slow release fertilizers that right rate release of nutrients to reduce eutrophication, and then also efficiency. So you want the nitrogen, phosphorus, potassium, whatever you're putting down on your field to be available when your plants need it, and you don't want that leaving the field. You want to make full use of it. And biochar has shown that it can do that in numerous crops. And that's all I have. Thank you very much.
Questions for Derek? Go ahead, Jessica. I see your hand raised.
Thank you. I really appreciated that. And I have a background in stormwater management, so I've heard about some of the applications that you were talking about. I was wondering, in the stormwater management use of biochar, how long does it take for that to get saturated? Like, how often would you have to replace the media that you have the biochar in, and how expensive is it to utilize it in that kind of way?
Yeah, great questions. So for the contaminant, it really depends on the loading, in the water, as well as the biochar itself. A lot of people say biochars instead of biochar. So you have some biochar that's closer to activated carbon, and you have, some biochars that are higher ash content. They're less able to bind with certain nutrients. So you really want to tailor the biochar to what your goals are. And then as far as reaching saturation, it depends on the contaminant. So if we're talking about hydrocarbons that can eventually be decomposed through microorganisms, you can also inoculate biochar with select microorganisms to speed up that. So through phytoremediation, mycoremediation, that kind of thing. And so you wouldn't need to replace the biochar at all. You can just leave it at the site. If you have a really contaminated site, especially if you're talking about like mine runoff directly from a mine that's high in heavy metals, highly acidic, things like that, you'd have to treat it more like a filter that you're replacing, the cartridge, quote unquote, with new biochar. And so that could be, like those steps, waterways that were shown in that Washington example, or you can be a more industrialized process. And so that said, biochar, you could either make it in a campfire, or you can make it in a highly controlled industrial process, and that affects the price and also the applicability of biochar for whatever your target goals are. But generally, you're looking around the cost of $10 to $20 per cubic foot. So it's not super expensive, but it's not necessarily cheap either. For a broad scale application, it can be expensive. If you're using this for like nutrient reduction in waterways or things like that, something that's not considered a contaminant unless it's in high concentrations, then you can use that as fertilizer. Then you have kind of that cascading benefit of pulling nitrogen and other nutrients that you don't want, and putting it areas where you might want it. And also, there's some some contaminants that, again, they're not bioavailable anymore. So as long as it's not like a chronic issue, if it's an acute issue that you're solving, you might be able to leave it at the site. But if it's a chronic issue that has reoccurring contaminant flows, then you would need to replace again, the quote unquote filter that you're using. But I can't really give you a solid, answer on that, just because there's so many variables.
Sure, of course. I have one more question. If I don't want to take away anyone else's time for questions too, Karen.
Go ahead, Jessica.
Okay, my final question is around the in-channel biochar diaper.
Yeah.
So what do you do with that? Does that become like a biohazard after you remove that from the stream? And like, how do you dispose of that?
Yeah, I can't remember exactly where I pulled that picture from, but it was it was a court case that more or less required that to pull chemical contaminants out. It wasn't agricultural runoff or anything like that. So in that case, it would have to be landfilled. It would be considered hazardous waste. And that's just the reality. To get it out of the native ecosystem, they thought that was the most cost-effective way to do it. But yeah, the assumption is that those diapers, once they reach saturation with those target contaminants, then they're removed and landfilled appropriately.
Right. Okay, thank you.
Yep.
Any other questions in the room? I just one question, which was related to the production of biochar. And, if you're using biochar as like a carbon offset, but like if you have to burn trees to get the biochar to begin with, how does that kind of dynamic equal out or
yeah.
balancing?
Yeah, no, and that's a very common question, because it's like, well, you have to burn it, and that's releasing carbon dioxide and other potential greenhouse gases, but it's an exothermic reaction. So once you have it going, you can redirect the syngas that's produced. So you're basically cooking off the volatile compounds in the wood to clear those pore spaces. So the tars, the combustible compounds, they get pulled off, and they can either be redirected back to the process to keep that fire going, or it can be used to produce like bio oil. It can be condensed and turned into bio oil, or used as a natural gas substitute, in industrial processes. But it takes less energy to get the process started and get it going than is locked away in the biochar itself. So that carbon, like when you're looking at biochar, that's, in most cases, 90 to 100% carbon, depending upon, the quote unquote purity of the biochar. So that's all carbon that would have otherwise been lost to the atmosphere, either through burning or decomposition. So we're removing that carbon from the carbon cycle, and it's recalcitrant carbon. So it takes very long amounts of time for it to be decomposed, if ever. You know, we have soils that show, you know, this resistant carbon, you know, 3,000, 2,000, 1,000 years. And depending upon how it's managed, it could last in perpetuity, really.
Very interesting. Thank you, Derek. Appreciate that.
Yeah,
I think we'll
thank you.
transition now to our next speaker. So Guinevere, if you want to share your screen, please.
Yeah, look.
Looks great.
Okay, great. Thank you. I am Guinevere Nelson, and I am with Colorado State University Extension. Prior to Extension, I ran a watershed group in Creede, Colorado for about 10 years. And so just really excited to share this experience and talk about the great work of watershed groups in the context of mining and water quality. Oh, next slide. Hang on, sorry. There we go. Okay, Colorado has a pretty crazy geologic history, and what you really want to take away from here is that Colorado had a lot of volcanic activity in the mineral belt, which is described here in this blue region, basically going from Durango to Jamestown-ish in that north-northwest trend. And this is important because it brought a lot of the metals that we mine, so gold, copper, silver, lead, molybdenum, into the mountainside, but it also brought a lot of sulfur-rich ores. Those are two important themes throughout the rest of this talk. But you can see there's a lot of other mining that happens, but this will focus specifically on hard rock mining and heavy metals. So I really like this historic photo. In 1858, gold was found at the intersection or the confluence of Cherry Creek and South Platte River. And I imagine this guy on the left was finding that gold. This is placer mining, which is like the oldest type of mining in the history of the world, basically using water and agitation in a gold pan or in a sluice box to separate the heavy metals, which are actually heavier than the alluvium in the creek stream. What we found as people were moving into Colorado with mining frenzy was that not only was there metals in the alluvium in the creeks and streams of Colorado, but we also saw some in the mountainsides. And there was some technological need to advance to really mine this silver or gold out of these mountainsides that we didn't previously have. So on the left-hand side, you can see a silver vein running through this mine. And so really we were like, how do we get at this material to mine it and recapture the silver? So in the 1870s-ish, right around statehood, we developed all this technology. So we had a lot of these jacks on the left-hand side that were hydraulic or steam powered, and then these stamp mills that are in the middle. And really this same idea was to take that silver or gold ore that was connected to other sulfur ore and crush it in these stamp mills and really take the silver or whatever mineral that we were after and then get rid of the waste rock. And you can see in this right-hand photo that that lighter colored waste rock is a result of heavy mining, and I believe that's in Cripple Creek. So lots of changes to the surface of the community through mining. This also opened up many tunnels into mountainsides. This is the Nelson Tunnel in Creede, no relation, and it has miles of workings underneath and connects all of these mines throughout the Creede mining district. And this is problematic because it exposed our sulfur-rich ores, or often pyrite, to oxygen and water, which really created this sulfuric acid, iron 3 hydroxide in the water. So really problematic because in those situations at a very low pH, probably 6 to 0, you have all of these crazy bad actor minerals like beryllium, aluminum, cadmium, mercury, lead, uranium. My son told me this morning, thallium's really bad for your lungs as well in solution. So basically that allows all of those metals that were sitting and waiting in the rock to get into our waterways. This causes two issues in Colorado, largely a point source of pollution, which under the Clean Water Act, local watershed groups were not allowed to touch. That was for higher EPA and folks like that to touch, but really pervasive throughout Colorado. And then, so that's the Gold King mine that we all pretty much know after 2015. And then the lower photo is non-point sources pollution. If you remember that photo of the waste rock from the stamp mills, this is an in-color photo, and this is the amethyst mine near Creed. What's important here is that you still get that same sulfuric acid created when snow will melt and run off of those big piles, those lighter colors of waste rock, mobilizing those heavy metals. And then you can see East Willow Creek there in the bottom. So it would take all of that heavy metals that was still remaining in that waste rock into the creek. This is a map of all of the mine sites in Colorado. I believe the yellowish ones are ones that have been closed, but don't quote me on that. This is from the Division of Reclamation, Mining, and Safety, but very pervasive problem across Colorado and potentially in water quality. So big problem. This is from the Public Health and Environment Department. And basically, if you look here, this is all the waterways in Colorado. A quick way to synopsis is blue and green water is okay, but once we get into the red and the yellow streams, those are really critically impaired and do not meet surface water qualities. So we have a real problem with a lot of those heavy metals mentioned before. I think lead and cadmium and sometimes arsenic, and I think those are the big ones that we're dealing with in Colorado across the mineral belt. On the eastern side, it's a little bit different story, and those have different attainment issues. So Erik alluded to this a little bit, but the EPA has all of this responsibility primarily for the Clean Water Act, but those other acts listed also have some mining component to them. So they are the regulatory agency that oversees that. In Colorado, we're able to do, through an MOU with EPA, some of the work locally through the non-point source program. And then the Water Quality Control Commission takes the Clean Water Act directives and really makes them specific to Colorado. So you can see there's lots of regulations about what each water and waterway can and should be at based on the chemistry and water quality collection data. We also have the Division of Reclamation and Mining and Safety, and they're just a partner in the Department of Natural Resources who really works to reclaim. And then if you've ever approached a mine that has a big vault or a gate over it, that's probably them. They're also bat friendly, so that's cool. And then that comes to the watershed group. So in the early 1980s, after the Clean Water Act was enacted, these were created across the nation. And the thing I love about these is that they're locally led. So there are people who are excited, whether it's like your retired chemist or a local town councilman, they're engaged in these watershed groups, and they work with EPA and the health department and DRMS to convene. We build stakeholder support, collect data, educate. I managed projects, which was pretty awesome in my role when I did that, and then worked to talk about the information that was collected and the change that was enacted, and then celebrate success. And then as that map you saw, there's tons of mine work to do, so they do it over and over and over again. And so really important part to engaging in water quality across Colorado is to interact with these watershed groups. There are about 75 watershed groups across Colorado that are really active, and I tried to find a map, but I couldn't, but they're everywhere, just so you know. And then I think what's also important is that it really takes a lot of work to do this watershed work. So when I was the executive director of a nonprofit, these are just a sample of people that I worked with, from like local mining corporations to volunteers to basin roundtables, the EPA, Trout Unlimited, really important people to have at the table to get funding to document the water quality impact, to really work with the mine waste if that's necessary, and really takes a lot of coordination and collaboration. But if you want to invest somewhere, I would highly advocate to invest in watershed groups, whether that's volunteering, serving on a board, donating. They really do a lot and have made great impact on Colorado's waterways. And that's all that I have.
Questions for Guinevere? Yeah, go ahead, Neil.
Yeah, that's wonderful, Guinevere. I used to be involved with the Big Thompson Water Forum. I don't think they're as active as they used to be, but I certainly support what you said about the nonprofits. Are there any of them that are really big and have a big impact, that we can almost work with, like as a partner at CSU?
I'm sorry, did you say, are there really active watershed groups within CSU? Was that the?
Really big and influential. I mean, there's some that are so small, that it's hard to engage with them, but some of them are bigger, almost like a national environmental group or something.
Yeah, I'm not really sure about that, and I think it could be a really cool way for the Water Center and with Extension to interact in these local communities. But I'm not aware of it. I wasn't aware of it when I ran a watershed group, but that doesn't mean it doesn't exist. So that could just be me not knowing.
Right. Well, another opportunity for the Water Center to reach out and partner with a bunch of stakeholders.
Yeah, I mean, I know, just locally, the Coalition for the Poudre River Watershed and the Big Thompson Coalition are the main ones here. But there's, Ark River. Gosh, there's a lot out
Collaborative.
there.
Yes.
Yeah.
Lots. Yeah.
But that would be interesting, like if there is a kind of if you have that list, Guinevere, and kind of bringing some of those resources together and conversations together would be, and then
Sure.
finding partners with CSU. Yeah.
Yeah.
I'd love that. I think it's really important work, so I would love to work with you on that.
Any other questions for Guinevere? Okay, thanks, Guinevere. Let's get our last presentation pulled up here. Thanks, Debbie.
All right, thank you so much. Those were great talks, and I feel like there was a lot to learn here. I'm very new to CSU in Colorado, and so I've looked for it. So I'm Debbie. I'm an assistant professor in the Department of Environmental and Radiological Health Sciences. It's cool. A little bit about me. I'm an environmental health scientist, and so I study the relationships between environmental exposures and human health. And so my focus generally is on water quality. I study private wells, public water supplies, irrigation water, recreational water. My hope is to characterize the microbial and chemical quality of various water sources so that I can determine the risks to human health. I focus a lot recently on private wells. Why private wells? There are a lot of estimates that 13 to 17% of the US population might rely on a private well. These are not federally regulated, and so households are responsible for monitoring and maintaining their own wells. Unfortunately, this often means that households are consuming their well water untested and untreated. And this might be okay, but the problem is that we just don't know what the quality of their water is like. And there is evidence of, there's increasing evidence of microbial contamination in some of these water supplies. And so a lot of my work has been in Pennsylvania. This is a map of private well density in the US, and you can see how in Pennsylvania, there are a lot of wells, and there are also areas where it's quite dense. This is where the wells and enteric disease transmission trial comes in. It's the first randomized controlled trial globally of its kind. And the point here is to look at the impact of private well water quality on gastrointestinal illness. And we do this using a randomized control trial design where we assign half of the homes to a UV water treatment system and half of them to a sham system, so kind of like a placebo. But we know that UV is effective. So we're not really trying to see whether or not UV treatment is effective here, but rather we're trying to show that the absence of treatment, so if you're consuming untreated water, that might be associated with gastrointestinal illness. So after we install these devices, we follow these households for a year and compare gastrointestinal illness in their children under 5. In addition to collecting disease data, we have samples. We have paired water and stool samples that we analyze for common waterborne pathogens. And then we also have some saliva samples that we collect monthly. And we look at those for antibodies to common waterborne pathogens. For the water samples, we have grab samples where we use membrane filtration to test for fecal contamination. And then we also have these ultrafilter samples where we filter 800 liters of water through a dialysis filter. And that way we can bring that sample to the lab, we elute them, and we can analyze them for common waterborne pathogens using qPCR. The full trial is ongoing, but I have some pilot data I wanted to share with you guys. So in terms of the grab samples, we found that nearly all wells are positive for at some point for total coliforms, and nearly half of them were positive for E. coli at some point. To put this into context, public water cannot have any E. coli in it. So we also have our ultrafilter results. We found that salmonella, noro, rotavirus, crypto, giardia, and human bacteroides in these ultrafilter samples. And so with human bacteroides, that's suggesting that there's human fecal contamination going on in these water sources. And that might be from septic systems or leaky municipal wastewater, right? So the idea here is perhaps these groundwater supplies are not as pristine as we might have thought. And so since coming to CSU, I focused a lot on the private well water quality space in Colorado. So obviously not as much in Colorado compared to Pennsylvania, but still a huge population, I think, along the Front Range. So I've been collaborating with Carl Job at Boulder County Public Health and Umit Shrestha at the Colorado School of Public Health to work on a private well stewardship project in Boulder County. We sent out 10,000 mailers to Boulder County residents who have septic systems. So using their records, we provided them with a QR code to a Qualtrics survey. In the survey, we wanted to get a better sense for their management practices and their perspectives. Really, what are their motivations for testing and treatment? What are their barriers? Generally, what they think about private well water quality and what would motivate them to do something about their water. We had an overwhelming response. We got 814 responses in 1 month, which for this kind of work is huge. It was I was shocked. And in terms of a survey incentive, we provided water testing for the first 200 respondents. They were eligible for it. And we will test them for coliforms, nitrates, and metals. And this sampling will occur like late spring, early summer this year. Again, our survey analysis is ongoing, but I wanted to provide some preliminary data from our Boulder County survey. Nearly 2/3 have gotten their well tested. Very shocking. That's really rare. But again, it's kind of biased because these are the folks who are super passionate about filling out this survey immediately. So nearly 2/3 have gotten their well tested. Unfortunately, only 2% have tested yearly, and that's the recommended frequency. A lot of folks don't test yearly. This isn't that surprising. And nearly half of them treat their well water. Also really surprising. That's a really high percentage. But there's a wide range of treatment options here, ranging from like a Brita filter all the way to like a reverse osmosis or an ion exchange system. And that was surprising. Really shocked by the Boulder County residents who really came out with her well water. And we also found that 1/3 of folks were not confident about some well management strategies, like in terms of following an emergency, like a wildfire or flooding event. They weren't really sure what they should do. And so at this point, the survey is intended for us to get a better sense for what their needs are in the community and how we can better support them and especially increase private well stewardship. That was.
Yay. Questions for Debbie, online or in the room?
First of all, I'm frightened. The level of interaction that you have with people with all those wells is really important. It's really critical. You know that way better than I do. I'm a forester. I just worry about the trees, but are you going to expand what you're doing in terms of those contacts, or are you already doing everything that you possibly could?
Certainly not everything we possibly could. I think we really do want to expand. the opportunity to collaborate in Boulder County, came up, and it was just a great choice, given what Boulder County is already doing in this space. But I find, well, I'm new to Colorado, so perhaps I'm wrong in saying this, but I think Boulder County is likely an anomaly, in the terms of, private well stewardship practices in the state. So I'm curious if we were to expand throughout Colorado, what we would see and what the needs are. I imagine it's very region specific, and I think that that would be a really great opportunity to partner with the Colorado Water Center and CSU Extension, right, to reach the community in this way. There are other extension programs in other states where extension is involved in this private well programming. In Colorado, that doesn't exist. And so I think this would be a really great opportunity to go in and use this network. I feel like extension is a critical resource that people trust. I know a lot of people are looking to CSU for a lot of important information. So I think this would be great to reach out and support the community in this way.
Yeah, so Debbie, I'm gonna reach out to you because my program has we're an ag program, but we just for basically the need that you kind of described, we have a well and septic educational package.
Oh, really?
So
Wow.
we have a document called Protecting Your Private Well, and then we have some folders both for private wells and septic. But which we're about to update. That's kind of next on our list of things to update, but I think it would be a great partnership with the work that you're doing with folks in Boulder County and then beyond to have those materials available for when you're making these connections with folks.
Right, right.
To also have these educational materials, and we'd love to get your input on them as well, so. So yeah, I'll share those with you, and then, but I think we should stay connected.
Definitely,
Yeah, we've talked about, trying to connect more with extension and get some funding to do like a statewide survey or update educational materials and get those out to people, because there's clearly, a need and people just don't know potential
We have
risks
some
and
good
hazards.
materials that need updated, so let's.
Yeah.
The three of us can kind of collaborate and.
Great.
Yeah, chase some funding maybe, but I
Yeah.
think there's a great opportunity there.
Yeah. And I think oftentimes when people find out, they're shocked, and once they know, it's hard to look away. But I think generally I hear a lot of people thinking that their wells are clean, they love the taste, right? So.
Sure.
I think,
Yeah, and we've talked like my own parents, they're on a private well in Illinois and in very agricultural area, and they're proud of their well, but do they get it tested? No.
Yeah. And when I look over some of the survey responses, folks say they would test if there was evidence that like some sort of health outcome or if something had happened perhaps, but so far they haven't had any issues, so why would they do anything?
Yeah.
Which is fair.
I was gonna ask, in your surveys that you're doing right now, do you collect any like economic data or income? Okay, you do. Good.
Well, for those who are willing to
Okay,
disclose that information.
because I'm sure that has an impact on like how often they test, or because if they have to pay for their own testing,
Yeah,
it's a factor.
it's pretty expensive.
Yeah.
And it takes a lot of time to do that and seek out the testing options. Right now, CDPHE is not even collecting, doing water chemistry testing. They're on hold, I think. At this point, I don't know right now where the private will come in. They would have to seek out other options.
A lot of county health departments will do it, but
Why is it on hold for CDPHE?
Something happened.
Oh.
Yeah, but it might be back online at some point. See.
Great. Any more questions for Debbie?
Do more.
I do.
Oh, that wasn't the question, I'm sorry.
Go ahead.
Exclamation mark.
Go on.
Thank you, Debbie. I'm Jessica Thrasher. I also work at the Colorado Water Center. I do a lot of work with mobile home parks and water quality. So I would like to talk to you extensively. And you mentioned that, and I just briefly did a Google of this, but the chloroform, how much chloroform should be in water?
Oh, that it should also generally be, there should not be coliforms in the water as well. But I think that there are, in terms of, it depends on, I'm trying to think of where there shouldn't be any coliforms in the public water supply. But I think that that one has probably a little, the way that they test it, there's a little bit more give, I imagine, where it's not as though it's an immediate cause for alarm, where that would lead to supplemental testing for E. coli.
Gotcha. Yeah, I'm looking at the results from, there's a testing program right now with CDPHE and the mobile home park water quality. And so I'm looking at the test results and would love to talk to you about those and see how we could do potentially some partnerships around this area. I've been working with the mobile home park specifically in Larimer County, but it's an issue statewide. And so that's another community that has a significant amount of water quality issues.
And I didn't bring this up here, but I feel like especially in small communities, water systems, they really struggle with compliance. And so the issues that are prevalent in private wells, I think, are on another level, like the small community water systems often struggle with the same.
Yeah, great. Well, I'll definitely reach out. I appreciate your presentation. Thank you.
Yeah.
All right. Well, now we're going to open it up for general conversation between all of our speakers. So I'm going to pull up our Zoom folks so we can see. Maybe. Okay, so let's maybe Derek, if you can also bring your video up, and we will have a conversation. So can everybody see each other here? Yes. Okay. So in general, I guess, Debbie, you want to
Yeah.
come in? Are there things that you heard between, I guess we were just talking about them, but you know, what were some things that might have sparked your interest? Online folks, are there any synergies or collaborations that stand out to you kind of immediately from these presentations, or anything you want to follow up on?
Well, one of the things after Debbie's presentation is that, so in addition to what I mentioned, the private well and septic, you know, education and outreach piece, which is important to us. But one of the other places where we sort of cross over is with the new Food Safety Act passed in DC.
When was that passed?
Last year, I believe. But a big issue in agriculture for anyone who's producing edible crops, essentially. So, you know, leafy greens, carrots, onions, anything like that. There is a huge push in agriculture where in your irrigation water, so not even the end product, but the irrigation water, for looking at and testing E. coli and coliforms both, and essentially with zero tolerance. So if you have any E. coli, any coliforms, you're not allowed to irrigate a food, readily edible food crop, which is a huge burden. I know some farmers who have stopped producing vegetables because they're just the regulatory burden is too much for them to address this. So there's a lot of crossover with the, you know, concerns for water for human consumption, but also for food production and E. coli and coliforms and how that could impact things that folks ingest. So there's a lot of, there's a shared need for protecting water quality from any kind of cold bacterial, you know, issues. coliforms, whether it's E. coli or not. If it's a fecal coliform, no matter, if it comes from geese or
Yeah.
deer or whatever, it's still an issue, right? And so that's a big overlap where, for human consumption, it's a huge problem, but also then it goes to food production as well.
And are growers in Colorado primarily using groundwater for irrigation, or are they also, is it a mix with surface
A
water?
very big mix. Yeah. A lot of both. Yep. And a lot of it, some of our best vegetable production ground is north of Metro Denver. And a lot of that, there's groundwater involved, but a lot of it's diverted water out of the South Platte, which at some times of the year is literally 100% Denver Metro effluent, right? So it's, which they're treating, of course, but it's still, it's coming through the human, the human biome and then, into the river and then getting diverted for growing crops. So it's a big mix. Yeah.
Especially the total coliform, that is so difficult to achieve zero total coliform.
It is, because that's part of, that's
And
nature.
that's the
Coliforms
standard?
are part of nature. Yeah.
That's the standard that you have to,
Yeah.
requirement?
Yeah. And it's not only the Food Safety Act, but it's it's driven even more by the purchasers. So it's the growers of the world or the King Supers, because they don't want the liability. And so the Food Safety Act might have a little bit of flexibility, kind of like you were saying, like, you can find total coliforms at, whatever, a number of 5 once, as long as it's not consistent or whatever, and you're okay. But for the buyers, they're like, it's got to be 100% across the board. And so it's the market that kind of drives that, as much as the regulatory side of things.
Jessica, is your question related? Because if not, I'm gonna continue on this. I have a follow-up question.
Yes, it's related. So I was just noticing kind of the connection between the presenters and really an opportunity for the Water Center to be able to amplify this work and to connect to resources. And that is something that we are doing and would love to do more of. And really that another piece of the work that we do, or the work that I've been doing, is around translation of some of these. So Erik, you were talking about creating new resources and having those available. So that is something we would love to work with you on. And from CSU Extension, there has been our OEE in general has been a connection to more of that translation as well. So I just wanted to highlight that.
Yeah, thank you, Jessica. So you're talking about translating into other languages? Is that what
Correct.
is that interpreting? Yeah. So we've actually, a lot of our well and septic information when I first started in my position, which is a long time ago now, but we translated a bunch of it into Spanish, and definitely something that we would be interested in pursuing and revising. And I'm fluent in Spanish, but I had a woman from Colombia help me make sure that it was, accurate and valid. But definitely something that my program would be really interested in. And a lot of the ag community we work with, a lot of the folks living in labor communities and things, it's Spanish, or it could be the Hmong community, that speaks Vietnamese or Laotian or something, right? So I think there's a lot of need for that, and something we'd be really interested in supporting. Absolutely.
Fantastic. Yeah, I have connections. I was just blanking. It just left my brain as soon as I was like, I know someone great. I can't think of it. I'll put it in the chat when my brain re-engages. But yes, we work with an organization that translates into so many different languages. And so would love to connect you with them.
We would be very interested in helping with that. So.
Okay, thanks.
I was just gonna ask, in a case where there is contamination, and I'm sure there's a range of sources that it could be from, but like, what is a typical response or mitigation of some contamination of a private well? And then how might that relate to, let's say you have a farmer who's irrigating vegetable crops and they find, a bunch of coliforms in there. Are kind of the mitigation possibilities prohibitively expensive, or sometimes they're like easy fixes?
Especially at the household level, they range. And so you can have treatment systems that are relatively affordable, and then, there's also, I think, an opportunity here for public health to step in, because I've also talked to folks who have been sold water treatment systems that are essentially just souped up versions of really very simple systems, and then they're being sold these very expensive multi-tank, several thousands of dollars. And so, but there are treatment systems, and I think this is where especially that engagement can be helpful, of what are the treatment options and at the household level. And so there are a lot that can range, and some more affordable than others, but also I hate to see when people are.
Yeah, and those are some materials we do have that again could use
Nice.
an upgrade essentially with input from you and others. So yeah.
And it really depends on what the problems are, right? So if you are concerned with metals, you might move to a different kind of system. And if you have a microbial issue, you could have another system.
Right.
Notably in the study, we used UV. It was because it was effective, but also so that it wouldn't impact taste. So there are a lot of other options that we could have used, but in order to keep the blinding, so everyone is blinded, everyone. So in order to make sure that you couldn't tell that your water was treated, it was used. So yeah, but depending on, and so that doesn't address other metal contamination.
Right, it's great for cold forms, but yeah.
Derek and Guinevere, any collaboration thoughts or opportunities triggered for you?
I think I'm pretty excited about the translation. That's always something that I think is really important. So yeah, let us know if you need some push for our. I'm sure Jessica will cover it. So, but if you need something else, let us know. I am just really excited. I think that water as a whole is an important topic, and I think in Colorado, quantity gets a lot of the conversation. So I'm really excited to think about how to, as a whole, talk about water quality as a state and CSU, because it is, as we get less and less water through the snow cycle. And I was just reading something that climate change is increasing the heavy metal contaminations in these mine sites. It's going to become more of a critical issue, especially as we have more people needing the same amounts of water. So I think water quality as a whole could be a theme that we address. In terms of wells, I'm not very familiar, and heavy metal treatments, I'm not very familiar with that. I know that I worked with the city of Creed on their water source, and it seemed like a lot of really expensive treatment options to get heavy metals out. So I don't know if Derek has anything on the efficiency of biochar in those kinds of municipal water. I know that's not really well related, but I think that small communities also struggle with getting heavy metals out of their water systems as well. So
yeah, and to kind of build off that point, like Guinevere said, I mean, Colorado has a history of water use for millennia, for centuries, and that's only going to become more important as the state develops. More people move in, and the agricultural sector has to kind of adapt to that, as well as the conflicting uses and interests. So, I mean, specifically for my interests regarding biochar, there's multiple opportunities to incorporate biochar, again, either within water columns or within the soil columns, depending upon what the contaminant is. Like, for example, there's opportunities to, again, to dose biochar with targeted microorganisms that can help break down different bacterias and things like that, or again, pull other contaminants out of the water column. How they compare, cost wise to other methodologies, I can't really say. There is certainly, literature out there that's been done on these things. So that's kind of one aspect that, got my wheels turning. And then the other is that, interest in the water center and working with Extension, I definitely encourage that because Extension has boots on the ground in almost every county of the state. So if you're wanting to get messages out or bring together stakeholder groups, things like that, then certainly contact Extension staff to see how we can work together.
Just, I know that extension staff, not everyone has a water education. And so like, I think that would be really important too, is reaching out to extension staff to give them that education. Especially in these smaller extension offices, they're probably working with producers and, water education is hard and it would be great to arm them with as many tools in those offices as possible.
Absolutely. Yeah, this is on our list of things to do, both, to provide some online educational resources for extension, but then materials, if we can actually have a forum kind of focus on water education and giving out resources at the forum, and just make sure you all have the resources you need to then take to your communities. So that is in our minds and something on our list of things to do this year. So thanks for that.
Yeah, and one thing, one thing, Karen, that I think the Water Center could really play a role in, and not to give away any trade secrets, but as Derek said, for example, the CWCB, the Colorado Water Conservation Board, has always been very much quantity focused, like almost 100%. I've been rejected for a lot of grants. I'm not bitter, but however, I have some contacts there over the last year or so that are they are now understanding what Derek said, that you can't only focus on quantity anymore. That's kind of a thing of the past, that the quantity of water is one thing, but if the quality is terrible, then you have some issues. And so water plan grants are a really great opportunity, and something that, potentially for this group, like just thinking about the work that Debbie does and my program, sort of partnering in ways and working with Extension where we're trying to get that information out. That's the kind of thing that in the past the state would not have funded, and and CWCB now really has an interest in that, and I think a recognition of how important that is. And so I think, potentially with, maybe the Water Center as kind of the intermediary, because I know you work a lot with CWCB, but there's some real potential there for funds through the water plan. And those are significant funds, they go up to, I don't know, $500,000 or more for those grants, right? And so it's a place where maybe things like well and septic education and outreach, or connections with, Derek doing biochar stuff in an ag setting, that's something for like edge of field remediation, where we're looking at sort of edge of field bioreactors and things like that, right? I think there's a lot of potential there. And so I think those are always more powerful with some collaboration. And so I think, thinking about those opportunities where we can partner and maybe collaborate with the Water Center and sort of make those more powerful. But I think that quality has really become, it's hard to ignore, I guess, these days, right? It used to be always ignored, and now it's understood that quantity is great, but if the quality of the water is terrible, then you have issues, right? So, yeah.
Yeah, and that also brings up another water quality issue that I work on, which is salinity in the South Platte River Basin. And I know we're kind of out of time here, but I just wanted to ask Derek, if you're familiar with any large scale applications to manage salinity in agricultural production, and if that is a possible potential, solution for this, or at least management strategy, if it's been done before, and if that could be something, experimented with in the South Platte.
Yeah, certainly. So work has been done on, specifically saline soils and biochar use and the remediation of salts. And you have to pick kind of the 3 R's of biochar are right source. So what type of biochar you're using, right rate, so how much biochar you're putting down, and then right application method. So those are the 3 R's that you kind of want to consider. And then there are some biochars that have shown effectiveness in in improving outcomes that might be, they might have more of a mineral content that helps bind with the salts, like they might be higher in calcium that can help displace some of those ions. Or they just help reduce stress overall for plants. So you're improving growing conditions for plants, which allows them to better address kind of the excuse me, the osmotic stresses of, having saline water. So it depends on, what the water is being used for, and whether you're drip irrigating it or flood irrigation or, center and pivot, whatever the case may be, what you're looking at. In a lot of cases, biochar might not be the most cost effective, if you're just specifically looking at saline soil improvements, but it can be part of a regimen, some kind of treatment plan to improve outcomes on saline soils as a result of saline irrigation water.
Yeah, and we can follow up on this conversation, but with one of the things that we're talking about with the stakeholder group is as more and more, well, there's increasing salinity, increasing trends of salinity, and as more and more producers switch to pivots from furrow irrigation, they don't have necessarily that option to leach out salts from the soil, or do a one-time flush of the system. And so what are their management options, and is biochar one of them? So we can follow up on that. But yeah, I think there's a lot of potential collaborations, certainly among this group, and I hope the Water Center can help to bring some of those to fruition more. Any final comments? I think we're out of time, but any final comments before we wrap up here? And again, thank you so much for your participation in this.
Thanks for bringing this together. I think it's an important conversation.
Absolutely.
Yeah, same. Thank you very much.
Well, thanks, everybody. We're going to wrap it up, and please, no one has even taken any cookies or sweet treats. Please do that. Thanks, Erik. Thanks, Guinevere. Okay.
But nobody said viruses, so I wanted to mention viruses.